Okay guys, electrophilic substitution. Electrophilic substitution is the reaction that occurs in benzene. This is the only reaction that occurs in benzene, and these are the four different reactions that are in the A2 syllabus with benzene, and the mechanism of each of these reactions is the same, which is electrophilic substitution reaction. Okay guys, one important note over here. Whenever the examiner asks the mechanism, the name of the mechanism, whenever the examiner asks the name of the mechanism of any of these reactions, either halogenation, nitration, Friedel-Crafts alkylation, or Friedel-Crafts acylation in the past papers, so the name of the mechanism is always going to be electrophilic substitution. Okay, you are not gonna write halogenation as the name of the mechanism, or you are not gonna write nitration as the name of the mechanism, neither these two, but rather you're always gonna write electrophilic substitution as the name of the mechanism. Why aren't these the names of the mechanism? Because these are actually the names of the reactions, but rather than not the names of the mechanism, these are just the names of the reactions. Okay, because the marking scheme, it marks the electrophilic substitution as the correct answer and gives marks for that only, so keep this in mind. Okay, halogenation is the reaction that we've covered in the previous video. It is basically the reaction of halogens with benzene and substituting a hydrogen atom with a halogen atom. Now, in this video, we are going to talk about nitration, and then in the upcoming videos, we are going to talk about Friedel-Crafts alkylation and Friedel-Crafts acylation. Okay, now let's get started with nitration. Okay, now what is nitration? Okay, nitration is basically the addition of a nitro group to benzene. Nitro, nitro group, nitro group is basically NO2, and if I were to draw the structure of the nitro group, it's NO2 with a positive sign, positive charge. Okay, so NO2 positive, NO2 positive. Okay, guys, this NO2 positive is our electrophile. This is the electrophile in this reaction that is gonna react with benzene. Okay, now let's get started. The overall reaction, and yeah, let me write down the reagents of this reaction as well. The reagents used in this reaction are reagents. There are basically two reagents. The first one is nitric acid, HNO3. This is our nitrating agent. Nitrating agent. And the second reagent is H2SO4, the concentrated or dilute, either concentrated or dilute. Well, different in different reactions, so different conditions for different reactions. We are gonna talk about them in detail in the upcoming videos, or maybe in the same video. Let's see. Now, sulfuric acid is the catalyst used in this reaction, and nitric acid is a nitrating agent. Okay, so these conditions are important. The examiner asks us the name of the electrophile, or the conditions, basically the catalyst and the reagents. The reagents, so which means both of them, or the catalyst, just the sulfuric acid, or the nitrating agent, the nitric acid. The overall reaction when benzene ring reacts with nitric acid in presence of H2SO4 catalyst at a temperature of less than 55 degrees Celsius approximately. What happens okay, one more thing, this nitric acid used over here is concentrated, and the sulfuric acid used over here is also concentrated. Okay, concentrated nitric acid, concentrated sulfuric acid, and a temperature of approximately less than or equal to 55 degrees Celsius. The nitro group, the nitronium ion, basically it gets attached to the benzene ring as a substituent and forms a substituted benzene. This substituted benzene is known as nitrobenzene. Nitrobenzene plus water. Okay, this is our overall reaction. Now let's look at the more detailed mechanism of this reaction. And this mechanism is extremely important with respect to our A-level syllabus. There are many questions in the past papers mechanism. The examiner does ask us to describe the mechanism, so whenever the examiner asks to describe the mechanism, this is what you guys are gonna write. Okay, in the mechanism, the first step is the same. In all the electrophilic substitution reactions, the first step is the same. The first step is always to generate the electrophile. Generation of the electrophile. Now, how are we gonna generate the electrophile? And we know that the electrophile in this case is the nitronium ion, NO2 positive. Okay, well, it's simple. The nitric acid, HNO3, it reacts with H2SO4, forming hydrogen sulfate plus the nitronium ion plus the hydroxonium ion, H3O positive. Let's balance the equation. It's 2HSO4 and 2H2SO4, and I think it's balanced. Yeah, it's balanced. Okay guys, so now this equation over here, there have been questions in the past where the examiner asked us to show how the electrophile has been generated, and this equation over here has been given approximately 2 marks maximum. So it's better to learn this equation and the proper balancing of this equation. Okay, so this is the first step of this mechanism. Okay, now we have our electrophile over here. This electrophile will attack the benzene ring. So second step is the electrophilic attack on the benzene ring. So let's draw our benzene ring over here. Okay, now the NO2 positive ion over here, the electrophile. Again, curly arrows. Now the curly arrows, it's important to draw the curly arrows properly. They must begin from inside the benzene ring and must end and be pointing towards the electrophile. Okay, this is important because examiners are very strict when they are checking the curly arrows. So please be careful over here. Do not lose silly marks. Do not make these silly mistakes so that you lose marks. Okay, these marks are important. Okay, then the next step after this is the formation of the intermediate. The NO2 group. This curly arrow represents the formation of a dative bond from the electron density of benzene. So once the dative bond is formed, dative bond is formed by using 2 electrons. So 2 electrons are lost from the ring inside. As a result, the ring is broken. Now to make the incomplete ring, now remember how to make the incomplete ring. To make the incomplete ring, the carbon over which the NO2 is attached also represent the hydrogen over here, which is already there on the benzene ring. Any of the hydrogen can be represented. Okay, now represent the hydrogen and the NO2 on the same carbon atom on which the NO2 is attached. Now, immediate neighbors of this carbon, the 2 immediate neighbors of this carbon, start out drawing the ring from here and end it on the second neighbor. The ring must be big enough to cover all the 5 carbon atoms. Okay, it must be big enough to cover all the 5 carbon atoms, and since it has formed a dative bond, this means that the ring has lost 1 electron, because after the dative bond is formed, it acts as a normal covalent bond, and the second electron belongs to the NO2 group now. So therefore, this NO2 group, this NO2 over here, it gets this NO2 over here gets the electron from the electron density of benzene, and this electron density over here gets a positive charge. Okay, now this is our intermediate, the carbocation intermediate, which is also called the sigma complex or the valent intermediate. Well, the name isn't important. The examiner, I don't think, would ask you the name of the intermediate. Now, what happens next is this carbon-hydrogen bond. The electrons in this carbon-hydrogen bond are attracted to this positively charged region, and this bond breaks heterolytically. Now it's important to show this arrow. It must begin from the carbon-hydrogen bond and must end on the positive region inside. Okay, do not move the arrow forward or backwards. Okay, it must begin, the tail must begin from the carbon hydrogen bond and the arrowhead must end on the positive charge. After this bond breaks and the electron cloud inside is restored, forming the ring again, and our product, the nitrated benzene ring. This nitrated benzene ring is known as nitrobenzene, and we get H positive as the byproduct because H has lost its electron. Now what happens next is that the last step of this mechanism is this H positive over here. It reacts with the hydrogen sulfate ions which were formed initially and forms the sulfuric acid again. Remember the sulfuric acid? The sulfuric acid was used in the starting to generate the electrophile, and at the end of the reaction is regenerated at the end. The end of the reaction, it has been regenerated. So the sulfuric acid is our catalyst. Catalyst gets regenerated. So this is it about nitration. This is the entire mechanism of nitration, and approximately for 4 to 5 marks can be asked for 4 to 5 marks. So it's important, please learn it and be careful about the curly arrows. Thank you so much. Meet you in the next video.